Hey, welcome back to another video for our chessboard app. So I'm at the point now where I'm going to hand things over to you. This is the challenges page. So several things we need to do to make our board game better. The first is called out of bounds errors. And so the function we need to create is to check to see if a cell is safe. So let me show you what this out of bounds means. So I have a finished challenges on the screen here. If I put a knight at cell number 01, you can see that, let's see, type in knight, and you can see that I have a crash. It says the program is out of bounds here at the first line. So how do I know it's out of bounds? I look in my errors, and it says index was outside the bounds of the array. So the legal move of up to and over 1 is not on the board, and so it crashed. So I'm going to have to modify my program to check to see if this cell is legal. So I should put in a safety check first. So I'm going to invent a function called isSafe, or isLegal, or on the board, some kind of a method to let me know that this is a safe place. And so now, if this is a safe place, we will mark the board as a legal next move. So your job is to come up with a function that will return a true or false statement, is safe, and you can simply check to see if it's in the range between 0 and the size of the board. Let's run this again, and you'll see that the program will crash, but it will not crash on the first line. It'll probably crash on the second line. So let's try again with a number. Let's try 0 and 0. And let's put in the knight again. And you can see that the program crashed again. However, the first line passed. It was safe. And so the second line is now out of bounds. So that's the first function that you're going to have to develop, is a out of bounds error checking. So the second is input errors. So now an input error is going to result in a crash if the person puts in a string when we are expecting a number. So let's check to see how this try-catch thing works. So let's take a look at the program again, and we'll see that I've caught some invalid input. So now if I type in a string where it says enter your current row number, if I put in ASDF, the response says not valid, default set to 3. Now enter the current column number, let's try a 4, and let's put in knight again, and this time you can see that it set it at 3, 4. So when I sensed that there was a string that was input, I gave them a default number. You might want to ask them to re-enter their value so that it comes back as a real number. So I'll still have an out of bounds range if the person types in something like row number 133 and then column 5. And it says here, you have done something that is out of range, and it's using 3, 3 as its coordinates. So I checked to see if 133 was a valid number, and obviously it isn't. And so now when I type in my knight, I get 3, 3 as the coordinates. So I did check. The program didn't crash. You might want to ask the user to re-enter the number instead of just assigning them one, but we didn't crash. Okay, so the next is the challenge is for multiple pieces. So let's take a look at how the board will look if I use other pieces. So I'm going to put in a coordinate here, 3, 3, and instead of typing in knight, I'm going to put in the word rook. And you can see that the results are that the rook has a vertical and a horizontal movement. Let's run again. I'm going to put in something at 6 and 2, and let's put in the word bishop. And bishops work in diagonals. So not like a rook, but almost. It's a long diagonal. Okay, I'm going to try the king now. Let's try 6 and 4 and type in the word king. And you can see that the king can move 1 in any direction. So it's not a very powerful piece, but it does have flexibility and movement. The last is the queen. So let's see what a queen can do. So the queen is a combination between the rook and the bishop. It can move in horizontal and diagonals, and it's the most powerful piece on the chessboard. So I'll put some diagrams up here on the screen again. So we're looking for a bishop to be able to move. So the bishop uses diagonals. The rook is going to use a horizontal and vertical. And the king gets one spot in any direction. And the queen can go any direction for any distance. And so it's a combination between the rook and the bishop. So you're going to have to do some thinking of how to mark these squares. Now I gave you the results for the knight. So the knight was a freebie, and the knight's the most complex. So the other ones should be less of a challenge for you. So start with the king, that's probably the easiest. Then go with the rook, I would recommend. Then do the bishop and save the queen for last. The last item here is the print board upgrade. So you can see that I've printed an actual grid on the screen instead of a bunch of periods. So your challenge is to figure out how to print these. So do some experimenting with using print and print line. So when you print this, you're thinking that at the beginning of the row we're going to have a plus sign with 3 minuses, and then that's going to represent the top section of a cell. Then the next cell will be also plus and then 3 minuses. For a blank cell, we're going to have the dividing line here. That is the pipe character. If you look on your keyboard, it's right above the enter key or the return key on your Mac. It is the vertical line. And then I used 3 spaces to represent a blank cell. And so each one of these has a new blank cell. And then when you print a occupied cell, you're going to have a pipe character with a space and a plus sign and another space. And then for the X here, it's going to be the same. It's going to be a vertical space X space. And at the end of the row, before you finish the for loop, you're going to have one more pipe character. So do some experimenting and figure out how to print a grid instead of just squares of numbers. So there's your challenges. We've got out of bounds errors, input errors, multiple pieces, and changing this to a square board. So good luck on your challenges.